Tonight's beer continues on the seasonal tradition. This is Humbug Strong Beer from One Great City Brewing. They call it a fruited dark chocolate sour ale that even the Grinch would love. Ah yes, this is paying homage to another Winnipeg tradition. There's a guy who's been putting up a Christmas lights display on his apartment building for the last 40 years that says Humbug. You know that the season has finally arrived when you see the Humbug sign up. Yeah, that's definitely got some sour qualities to it. It's interesting, though. But, that aside, here is tonight's kit. There's a little bit more going on than the last one we looked at, including this huge IC here, which is an ICL 7107. We'll take a closer look in a minute. It's got a socket for it. That's nice. It's got one bent pin on it. That's not so nice. We have 4 7-segment LEDs, power, some diodes, one little 10-turn trimmer, a couple capacitors, a bunch of small resistors, and one larger one. And we'll figure that all out. And this interesting little double-sided board. It's going to be interesting. Let's see if we can find any information online about it before we dive in here. So this kit was made by a company called EQ Kit, and I found it all over the place. Here's the Banggood listing. I'll link to a bunch of these different places that you can get it. Oh, there's a link to a manual. Let's grab that. Well, that's downloading. It runs on 5 volts. It's got an measurement accuracy of plus or minus 1 milliamp. That's cool. It can measure up to 2 amps. Display color red. Yeah, whatever. There's all the stuff. Cool. But here is the manual from that download link. So again, we have the schematic, operating principle, nice. So that ICL 7107 has a BCD, binary coded decimal output, which faces the 7-segment displays. It's got an analog to digital converter, linear amplification, analog switches, all the rest of that good stuff. Vibration, I'm assuming that's oscillator, display drivers, yeah. We create a power supply on here, a dual power supply, positive and negative power supply. That's interesting. So the reference voltage is set up with, looks like a voltage divider with all these guys, plus the variable resistor, that trim pot that we saw. Yeah, the trim pot adjusts the voltage of whatever this translation error is, like the measuring circuit there. R5 is the measurement resistor. I'm assuming that means shunt resistor, so it's probably a really low resistance. A little bit of a debugging step. Okay, there we go. There is R5, which is in fact a low resistance shunt, a 0.1 ohm resistor. And then some diodes, a Zener, which is probably going to be part of that power supply circuit. Okay, this looks like it's going to be an interesting little thing to put together. And they've got a full set of assembly instructions in here. That is cool. This is a 12-page manual. Wow, there's a lot going on. Okay. So after looking at that manual, I think it's going to be prudent to actually follow the assembly instructions, especially when it comes down to the order of installation for that chip socket, which needs to be modified, and those LEDs. But I am going to go through things and just sort things out a little bit, because all 4 of these diodes look pretty much the same until you look at the part number. 3 of them are rectifier diodes, and the 4th one, this one here, is the 5-volt Zener. Let's just follow the manual, follow the step-by-step instructions, and go from there. And the first thing it says is, oh man, it's not giving you the values. It's telling you the color code, which is useless to me because I'm colorblind. Regardless, it's R1 and R9 is the first step. And according to the parts list and the silk screen, those are both 2K, which is these guys. And that looks to be the only 2 that are the same in the whole kit. I guess that makes it easy. Here we go. First components. Next is this resistor here, R2. It goes up in beside that poorly soldered resistor. I'm wondering if on this fairly tight little board I may be better served by a smaller soldering tip. That's working. Next thing looks like R6 over in the corner here. Whatever those colors mean. Oh, it's a 1 meg. Okay. Anyway, where was I? Oh yeah, right. R6, okay. And then the rest of the resistors. Okay, so I'll just bang them all in so I won't have to keep referring back to this guy. The other thing that I'm going to do is to switch to a slightly smaller tip, just so that I'm not getting in my own way here. R6 is the 1 meg. R7 is the 47K. R8 is the 20K. R3 is the 100 ohm. R4 is the 100K. And R10 is the 270 ohm. Get in there, you. Get. Yeah, that little tip is working much better. Next in, the 3 identical diodes, the 1N148s. These 2 up here are part of that negative voltage circuit. And this one down here is part of that reference voltage circuit. And then next is that Zener diode, again part of that minus 5 volt supply. Making sure I get the band the right way. Next is these 3 capacitors here. They're calling them monolithic. 3 different values, so I have to get that right. 104, 101, and 474. 104 there. 101 up there. And 174 there. And now we deal with the IC socket like this. That one goes there. I think add a little bit of blue tack just to hold it in place while I'm soldering. Let's do one end. Make sure that's tight. Do the other end. Make sure that's tight. Okay. Now the blue tack can come off and I will solder all the rest of the pins. Next, the 4 7 segment displays, paying attention to where the dot is with a helpful screen print. Thoughtfully, they packed them in foam so that the pins wouldn't get bent. Except for they did anyways. Okay, that's going to take a little bit of fiddling to straighten out, but it's not that difficult. There, 1, 2, 3. Okay, those hold themselves in there fairly tightly, so I don't think I'm going to have to worry too much about holding them, but I am just going to solder 1 pin of each one initially just to hold them in place. Yeah, they're still flat. Okay, I can get the rest of the pins. Some of them are going to be a little bit of a pain getting around this capacitor and whatnot, but that was a little cross-eyed, and there's a couple of them that don't actually have pads because they're the decimal points and don't matter. Like that one right there. Welding the second row home with the same directions. Wow, that's tight. Hope I don't melt the displays too badly. There we go. Make sure that's snug. Yeah. Pull my blue tack out before it melts and then do the rest of the pins. Eek. It already started melting. Yuck. Well, that was tight and fiddly. Well, it looks like I got them all. That's the main thing. Next, welding a transistor and a reference voltage regulator chip. Wait a minute. So U2 is the TL431A. That's the voltage regulator. But Q1, I don't remember. Hang on. Uh-oh. May have to rewind the footage a little bit, but I only remember one device coming out that looks like this. What is this guy? TL431A. Okay, that is the voltage regulator. That's the one that goes down there. But what about this transistor that goes up there? I have to look up the part number if I can't find it and see if I got anything that I can use as a replacement. That's annoying. I suppose an organized person should have taken inventory at the beginning here, but come on, you know who you're watching. Anyway, I can get this voltage regulator in here. Man, that's tight. They've done a good job of designing this board to cram everything into a small space, but makes it a little bit of a challenge. So now, about that transistor, C1815, what are you? Looks like an NPN. Yeah, it is an NPN. Okay. So I wonder if I've got just a basic NPN. I'll have to make sure that the footprint matches too. So what have I got in here for NPNs? I've got 2222s and I've got this single S9014 up here and 2N5551. Okay, I will just check and see what's got the specs closest to the missing guy, and I'll use that. It looks like all of these transistors exceed the specs of the one that's missing, but the one that's closest is the good old 2222. However, the pinout is not exactly the same. The base is in the middle of the 2222, so I'm going to have to put it in slightly askew. So there is the two pinouts. They couldn't be much different with only 3 pins. So I'm going to have to put this guy in backwards and then cross over the base and collector. And I think just for safety, I'll slip a little bit of heat shrink around there just in case. I hope that's going to work. I don't see any reason why it shouldn't. Okay, next step. 2 electrolytics and the 2 CBB capacitors. I wonder what that translates to. And of course, these guys are different. Well, it's a 104 and 224. They are clearly marked on the board. Making sure not to encroach on where the chip's going to be, because that would be problematic later on. The 2 electrolytics are both 10 microfarads. The negative is indicated, and the little banding on there indicates the negative. I know most of you know this, but part of the reason why I'm just saying it out loud is so that I actually think about it while I'm doing it, you know? As you've seen many times before, when I get so focused on making the video here, I sometimes forget about what I'm actually doing. Welding a sampling resistor, which is this guy here. So this is interesting. It's got a couple of holes there and a handful of holes up there that it could go in. It shows it on that one, and I think it just seems to, well, I'll just go all the way up to there. Is that going to fit? Perfect. This is going to be a bit of a tricky one to solder just because there's so much copper there. Next up, the potentiometer and the polyester capacitor over in the corner there. Looks like it's a 103. Yes, it is a 103. And it's also marked 103 on the board. Excellent. I love it when a plan comes together. And the potentiometer goes into that corner there. Next is the power socket and the measurements to screw terminals. Power socket. With that, I'm just going to double check that I've got it in the right direction. The black wire is on that side and it's marked negative. Yep, okay. And the measurement screw terminals, make sure I get them the right way. Yes, I have made that mistake before. Not for a while, so now I always check. Even the bloody obvious mistakes sometimes happen. Okay, what do we got left? Just the inductor and the chip. Why haven't I put the inductor in yet? Yeah, the inductor should have been going in several steps ago. Right, I can do it now. So as we saw earlier, that inductor is part of the negative voltage supply. Right, now that is everything. What are these little pads here? They look like they should be pin hitters or something, don't they? Short circuit decimal point test selections. Oh, that's what those are. Okay. So let me just bridge out these two pads here. I probably should have a little bit of wire or component lead or something in there. There we go. So now I think I will just power it on and check for voltage where I expect there to be voltage. Okay, got 5 volts set on the power supply. Plug that guy in. Plug that guy in. There we go. That says DC 5 volts in, so we know that's right. Power on. I'm drawing 7 milliamps. That's reasonable. That tells me nothing's shorted. That's a good place to start. So this thing is getting its oscillation, its frequency, from the internal oscillator of this chip. So I can't test the negative voltage until the chip is in. So I have to do a bit of a Hail Mary and hope for the best. But I think first I will set this calibration here, because I remember reading something about that further down. So let's just tinker that a little bit. It's quite twitchy. And I've got my negative just on the power supply negative, which should be close enough. Didn't want to have to hold it in here. Wow, is that ever twitchy? There we go. 100 millivolts. Close enough for me. And now, just gently straighten these pins without destroying them. I said without destroying them, you numbnuts. Come on. There's a lot of them that are tweaked. You can see the pin 1 notch over there. This is going to be twitchy. That was scary, but I think we got it. So pin 26 should be our negative voltage. Let's see what happens. Negative a little bit. Wonder how tolerant it is. I guess we'll just have to see. The digits on this side, that's a good sign. I think we may be in business here. As a matter of fact, I think the only thing left to do is mount it. That's fairly satisfying. Normally this thing doesn't have enough jam for self-tapping screws. That worked fairly well. I'm not going to strip them out, which is nice. And it still works. Good. So now I guess we ought to put this to the test. Okay, here we have one moderately janky test setup. I have red and black wires connected to the metering positive and minus on there. I'm not sure if this thing can measure in the negative direction, so I'm just going to do it in positive direction right now. I have this power supply set up to power this thing. I have this power supply up to act as a source for the measurement. It's currently set to 5 volts. And I have my USB load with the bodged on wire that I put on for another test in there, so I can use that as inputs to this thing. So if I turn this on and see that it is actually drawing 1 amp there, and this guy shows 7 milliamps short of that. So just turn him back off again for a second. Turn this guy on. Let it boot up. So it is showing currently is 0. You see that? Yeah. So if I power that guy on, this guy should start drawing 1 amp. Shortly. There we go. And this one is very wrong. What happens if I reverse these? Well, it is showing negative no matter what. Have I done something horribly wrong? Okay, that's showing in a positive direction anyways. So its calibration is way, way off. Because this guy says it's drawing 1 amp. That guy says it's drawing essentially 1 amp. I wonder if my substitution for that transistor caused problems. Although we were getting some negative voltage there, weren't we? Yeah, so we're only getting a negative 2.8. We're not getting the full negative 3 that we should be. Maybe I should have chosen a different transistor for that. So the oscillator is running on the thing. That's a good sign. Running at about 54.5 kilohertz. I'm not quite sure what's going on with that little power supply, but I'm pretty sure that that negative power supply being like almost half of what it should be is probably part of our accuracy problem. All right, then. Transistor replaced. I'm not even going to bother trimming the leads yet. I just want to see what happens. So measuring on pin 26 and power on. Minus 4.8, minus 4.9. That's more like it. I'll reconnect my janky test setup here. Power that guy on. Yeah, it's showing 0-ish. Power this guy on. I think this thing is set to draw 0.5 amp. Yeah, it's drawing 0.5 amp there. Well, that's a lot closer. 660 some. This guy says 5.1. We'll just turn it down to 0.5 amp exactly. I mean, it's not perfect, but it's in the ballpark. I'll just double check that calibration value again. And that's off, so put that back to 100 millivolts again. Whoa. Did I mention it was twitchy? So after doing a bunch of fiddling around, I decided to change out this 1K pot for a 10K just to try and get that calibration a little bit more stable. And now I've got 1 amp there, 1.028 there, and yeah, it's still bouncing around, but it's at least hitting the same range. So it's not the most precise of pieces of test equipment, but it's a reasonable ballpark, I guess. Would it replace any of my multimeters? No, not really. Unless there was something that I wanted, just a ballpark number at a glance from. And they can definitely do that. Oh, that's so much easier to read. I don't know why it's so twitchy and bouncing around, but like I said, that calibration value is a lot more stable with the 10K pot in there instead of that 1K pot. And replacing the transistor with one with a little bit different gain spec, and I'm wondering if I maybe had it shorted or something. I don't know, but replacing the transistor seems to have helped. There's the one that came out. Anyway, yeah, that's done. It's a reasonable enough thing, I guess. Like I said, it's not precision test equipment, but it's pretty close. So, I guess comments and questions down below as usual. You know the routine by now. I'm going to go and edit this thing and finish my beer, and I will be back next week with another kit build. I'll talk to you later.